Right now, in a data center outside Richmond, Virginia, a cluster of American engineers is running out of something you'd never expect a superpower to run short of. Not money, not chips, not electricity, though that's close behind. They're running out of words. Real human written words, the kind a language model needs to get smarter. Right now in Shenzhen, a completely different resource is piling up by the second. Video from 5G connected factory floors, sensor logs from autonomous delivery robots, a billion phones typing into a billion chat windows, all of it flowing straight into servers that never stop collecting. Right now in Washington, a room full of policymakers is congratulating itself on export controls that keep the best chips out of Chinese hands. And right now, on the other side of that wall, engineers are proving that the chip you can't buy matters less than the data you already have. 4 things happening at once on 2 continents, and only one of them gets talked about on the news. This is the part nobody wants to say out loud. America may be winning the chip war and still be losing the war that actually decides who runs artificial intelligence. This isn't a fringe theory from some contrarian newsletter. It's the conclusion of a bipartisan U.S. government body. In a report released in early 2026, the U.S.-China Economic and Security Review Commission, the congressional body, created specifically to track the strategic balance between the 2 countries, laid out exactly this argument in a paper titled 2 Loops, warning that as the internet's supply of high-quality text approaches its limit, the next phase of the AI race won't be won by whoever has the biggest model. It'll be won by whoever can keep feeding one. The nonprofit research group Epoch AI, whose data scarcity work has been peer-reviewed and presented at the International Conference on Machine Learning, estimates that leading American AI labs could exhaust the internet's stock of high-quality public text somewhere between 2026 and 2032. Not maybe, not in some distant sci-fi future. Within the decade some of you are living in right now. To understand why that matters, you have to understand what training data actually is. And the easiest way to picture it isn't technical at all. Think of a language model as a kid who learns exclusively by reading. Every book, every article, every forum post it's ever seen becomes part of how it thinks and speaks. For years, that kid had an entire library to devour, more books than any human could read in 100 lifetimes. But libraries aren't infinite. Eventually, the kid finishes them. What happens next depends entirely on what the kid does after the last page. One option is to keep rereading the same books, hoping to squeeze out something new each time. The other option is to go outside, get a job, start living, and learn from experience instead of pages. That second path is what China is quietly building. And it's the reason this race might not be decided by whoever has the smartest model today, but by whoever has somewhere new to learn from tomorrow. That framing matters, because for years the entire AI industry treated data almost like an afterthought. Chips got the headlines, compute got the congressional hearings. Data was just assumed a background resource like electricity that would obviously keep flowing because it always had. Nobody built an export control around a text corpus the way they built one around a semiconductor. Nobody held a press conference about a training data set the way they held one about a chip fabrication plant. And that blind spot is exactly why this story has stayed under the radar, while the chip war dominated headlines for the better part of a decade. Here's where the story actually starts. For the better part of 2 decades, the assumption inside American AI labs was simple. Scrape the internet, and the internet will provide. English language text, scientific papers, open source code on platforms like GitHub. That pool was so large it felt bottomless. It wasn't. Pablo Villalobos, the lead researcher behind Epoch AI's data scarcity studies, has confirmed that while newer techniques have pushed the timeline back from earlier, more alarming estimates, the underlying scarcity is real and not going away. Compute optimal training, the method labs use to get the most capability out of the least waste, is projected to exhaust the readily available stock of high-quality data by around 2028. That number comes from modeling how much text exists against how fast today's leading models are consuming it. And once a lab hits that wall, its options narrow fast. Pay enormous licensing fees for private data. News Corp signed a deal worth more than $250 million over 5 years just to hand OpenAI its archives. Generate synthetic data and hope it doesn't degrade the model or find an entirely different source of information that isn't sitting on the open web at all. That's exactly the gap China has spent the last several years quietly filling. While American labs were racing to scrape every corner of the public internet, Chinese researchers were asking a different question. What if you stopped relying on what's already been written and started collecting what's happening right now? Weinan Yi, an academician at the Chinese Academy of Sciences and one of the country's most respected machine learning scholars, argued in September 2025 that the next phase of progress will depend less on building bigger models and more on securing high-quality, diverse, real-world data. His argument wasn't theoretical. China's manufacturing base is now deeply wired. Connected factories, industrial IoT sensors, and 5G-enabled cameras generate a constant stream of specialized data that simply doesn't exist anywhere on the public internet because it was never meant to be published. It was meant to run a factory floor. And now it's training a model instead. Let's pause here and pull together what we've established so far, because this is the moment the story splits in two directions. On one side, American AI companies built the most capable models in the world on a finite resource that's now visibly running low, forcing them into a scramble for licensing deals and synthetic workarounds. On the other side, China stopped competing for that same shrinking pool of internet text altogether and started building its own private, continuously refreshing river of data from a billion connected devices. One side is fighting over what's left of a library. The other side went and built a factory that never stops printing new books. Now here's the part that connects it to something even bigger than factories and sensors: population. China has roughly 1.4 billion people, almost all of them operating behind a national firewall that keeps the overwhelming majority of their digital activity inside domestic platforms: WeChat, Douyin, Taobao, Xiaohongshu. Picture that scale two ways. First, against a landmark. That's more people generating data every single day than the entire population of North America, Europe, and Australia combined, all funneling their searches, purchases, questions, and conversations into platforms 4 Chinese companies can access directly. Second, against a time frame. The volume of everyday interaction those platforms capture in a single week rivals what it took the open English language internet years to accumulate in comparable form: 1.4 billion people. That's not a user base. That's a live, self-renewing dataset the size of a continent. This is where the two loops the US-China Commission described start to make sense. In America, AI investment overwhelmingly chases scale. Bigger models, bigger data centers, bigger compute clusters, an approach reflected in US companies spending roughly $694 billion on AI infrastructure build-out. In China, the strategy has leaned harder into deployment and application, cheaper models pushed into as many industries as possible, generating real-world usage data as a byproduct of simply being used. According to one industry analysis of hyperscaler spending, Chinese AI companies spent around $124 billion on infrastructure, a fraction of the American figure, while reportedly reaching close to 90% of top-tier model performance. If that estimate holds, it means China may be getting most of the capability for a small slice of the cost, in part because the data feeding those models doesn't have to be scraped, licensed, or synthesized. It's just there, generated by the country using the technology. There's a scale to Chinese AI deployment that's easy to state and hard to fully picture. As of early 2025, 346 generative AI services were formally registered with the Cyberspace Administration of China, more regulated, licensed AI products than exist in any other single jurisdiction on Earth. And because registration is mandatory, that number functions almost like a census of the entire domestic market. Baidu's Ernie bot reportedly reached around 300 million users. Alibaba's Qwen models have been downloaded roughly 600 million times worldwide. Tencent folded an AI assistant called Yuanbao directly into WeChat, a platform already sitting inside more than a billion phones, turning distribution that most Western AI companies would spend years and billions of dollars building into something that simply came pre-installed. Every one of those users, every question typed into every one of those apps, is a data point flowing back into the systems that trained them. It's not a research lab collecting data anymore. It's an entire national economy doing it by default, every hour of every day. Let's talk about the piece most people assume is the whole story: chips. It's true that US export controls have kept NVIDIA's most advanced processors out of Chinese hands, and it's true that Chinese domestic alternatives, like Huawei's Ascend line, still trail the best legally available American hardware. But something unexpected happened along the way. By restricting its own companies from selling top-tier chips into China, the United States accidentally created a protected home market for Huawei's chips to mature in without direct competition from NVIDIA's best products. And Chinese labs adapted around the compute constraint, the same way a runner adapts to a hill, not by refusing to run, but by getting more efficient with every stride. DeepSeek's models, released as open-weight systems that any developer worldwide could download and modify, demonstrated that competitive performance was achievable on far less compute than Western labs assumed was necessary, and they were downloaded at massive scale specifically because they proved the US compute advantage could be partially offset through smarter engineering rather than brute force. China's AI ecosystem now accounts for a large share of the world's open-source large language model releases, a strategy that spreads Chinese-built AI infrastructure into markets across the globe, embedding it into products and workflows most users will never realize started in a Beijing or Hangzhou lab. So even as the chip gap narrows more slowly than the data gap, China has found a way to make raw computing power matter less than it used to. If you're still with me, here's where it gets uncomfortable, because the story isn't just about servers and sensors. It's about people. Stanford's AI Index, one of the most widely cited annual benchmarks of the global AI landscape, has tracked something researchers call brain circulation, the flow of AI talent into the United States, historically one of America's greatest structural advantages. That flow is reversed. The number of AI researchers and developers relocating to the United States has dropped by roughly 89% since 2017. 89%. That's not a slowdown. That's a near total collapse of a pipeline that used to bring the world's best minds to Silicon Valley almost by default. Some of that decline traces to tightened U.S. immigration pathways for skilled workers. Some of it traces to China simply having somewhere better to go now. A domestic AI industry graduating more STEM PhDs every year since 2016 than the United States produces, according to National Science Foundation and UNESCO figures, and offering research infrastructure that increasingly rivals what's available abroad. China's AI research publication volume now accounts for roughly 23.2% of global output. And that figure isn't the product of a small elite lab. It reflects a large distributed research workforce spread across universities, state institutes, and corporate labs, all producing at once. If you go check the comments section of any video like this one, you'll usually find someone insisting this is all propaganda. It's worth pausing on that instinct for a second, because the honest answer sits in between blind confidence and blind dismissal. And that's exactly where we're headed next. But before we get there, if this kind of story, the ones connecting technology, geopolitics, and the numbers nobody's talking about, is the kind of thing you want more of, this is a good moment to hit subscribe, because we go deeper into exactly this territory every week. So why does any of this matter to someone who's never opened a research paper in their life? Because the models trained on this data don't stay inside research labs. They end up inside customer service systems, medical diagnostics, military logistics, financial forecasting, the recommendation engine deciding what you watch next, a country whose AI has been shaped by more real-world deployment data, more examples of how actual factories run, actual traffic moves, actual consumers behave, ends up with systems that are simply more useful at the applied industrial edge of the economy, even if its flagship research model doesn't top every leaderboard. That's the quiet, unglamorous kind of advantage that doesn't trend on social media, but adds up over a decade into something much harder to reverse than a chip embargo. Beijing's own strategic planning reflects exactly this priority. An AI plus action plan targeting 70% AI penetration across key economic sectors by 2027 and 90% by 2030. Alongside cybersecurity law amendments that took effect in January 2026, bringing AI development under formal law. Now, before this goes any further, it's worth taking a breath, because a story like this can tip very easily into hype, and hype is exactly what we're trying to avoid. So let's be honest about what isn't proven here. Nobody serious is claiming China has definitively surpassed the United States in AI capability, and the picture is genuinely mixed, depending on what you measure. American labs still hold real advantages. English remains the dominant language of the global internet, giving US models access to the most linguistically diverse, openly available text in the world. And platforms like GitHub give American developers a depth of high-quality code data that has no real Chinese equivalent at comparable scale. On raw frontier benchmarks, the tests measuring pure reasoning and problem-solving at the very top end, American flagship models still generally lead, and the gap, while narrower than a few years ago, hasn't closed. It's also worth being precise about the difference between population-level advantage and individual-level proof. The fact that China has more data doesn't automatically mean more usable data. A huge volume of short-form social posts and factory sensor logs isn't inherently equivalent in training value to carefully curated scientific text. And Chinese researchers themselves have openly acknowledged ongoing challenges with data quality, standardization, and governance as they try to convert raw volume into something a model can actually learn from well. And the data exhaustion timeline itself carries real uncertainty. Estimates for when American labs hit the wall range from 2026 all the way out to 2032. A 6-year spread that reflects how much depends on techniques, like synthetic data generation, that are still unproven at scale. To be clear, this is not a story with a settled ending. It's a story about which direction the numbers are pointing, and the direction is enough to take seriously even if the finish line is still years away. It's also worth separating what's been rigorously measured from what's still an estimate dressed up as a fact. Epic AI's projections are peer-reviewed and grounded in real dataset tracking, but they're still projections, built on assumptions about how aggressively future labs will train and how much synthetic data can safely substitute for the real thing. The spending comparisons between American and Chinese AI companies come from industry analyses, not audited public filings, and figures like an 8-to-1 cost efficiency advantage should be read as a snapshot of one moment, not a permanent law of how this race works. None of that erases the underlying pattern. It just means the honest version of this story has edges, not a clean straight line. There's also a question worth sitting with here, one that doesn't get asked enough in either country. What happens to a technology once the data training? It is no longer written by humans deliberately, but generated as the exhaust of ordinary life. A factory sensor, a delivery route, a chat message sent without a second thought. The Chinese approach doesn't just solve a scarcity problem, it quietly changes what kind of intelligence gets built in the first place, favoring systems tuned to the texture of real-world behavior over systems tuned mainly to the texture of written language. That's not automatically better or worse. It's just different, and different has a way of compounding into advantage or disadvantage over a long enough timeline. What makes this so different from the way the AI race usually gets covered is that it isn't a story about a single breakthrough or a single company. It's a story about structure, about which country built an economy that manufactures its own fuel supply for the machines it's racing to build, and which country assumed the fuel would simply always be there. The United States spent 2 decades treating the open internet like an inexhaustible resource, and for most of that time it was right. China spent the last several years building an alternative that doesn't depend on the internet running out or not. Connected factories, 1 billion phones, a population large enough to generate more raw behavioral data. Before lunch, then some countries produce online in a month. If you remember one thing from everything we've just walked through, let it be this. The AI race was never just about who builds the smartest model first. It's about who has something left to teach it after the library runs out. So here's where we land, back where we started. A data center in Virginia running, low on words, and a country on the other side of the world that stopped needing them the same way. Whoever wins this race won't be decided purely in a boardroom in San Francisco or a ministry office in Beijing. It'll be decided by something far less dramatic. Which side has somewhere new to learn from once the old well runs dry? That's not a headline you'll see flashing across cable news tonight, but it might end up being the sentence historians use to explain everything that came after it. Tell me in the comments which surprised you more, that America is genuinely running low on training data, or that China's real advantage isn't chips at all, it's 1 billion people generating data it never has to ask permission to use.